Hello everyone. In part 1 video of Favorskii Rearrangement, we have discussed the basic concepts and how the mechanism takes place of Favorskii Rearrangement. In this continuation video, we can see more and more examples and also the stereochemistry behind the Favorskii Rearrangement. Consider the example. Before that, we have to analyze whether the substrate will undergo Favorskii rearrangement or not. Here, alpha-haloketone is not present, but in alpha position, epoxide three-membered ring is present. In alpha position, epoxide ring is present, and also here one hydrogen is present. Hence, this substrate will undergo Favorskii rearrangement. Let us discuss the mechanism. Mechanism of this reaction involves all the Favorskii rearrangements involves three-membered cyclopropanone ring as an intermediate. So here epoxide group is there, and here ketone group is there, and here isopropyl group is there. So what is the role of the base? It will abstract the proton present in alpha carbon. It will abstract the proton, right? It will form negative charge, and here epoxide ring is there with the ketone group, right? And this carbanion undergo to attack the alpha carbon which contains good leaving group, and this bond will break, right? We have 5-membered ring with and 3-membered ring. Here CH3 is there and below OH is there. If it is below the plane and this, if then it will be above the plane CH3, and here isopropyl group is there, right? Again KOH will attack the carbonyl carbon. It will form O minus and OH along with this these group OH and CH3, right? How the major product will be formed means if the bond break by this way, or the bond may be opened by this way. Let us see A, this one, consider A and this one as B. Okay, I am considering pathway number A. A 5-membered ring has been formed, right? Here CH3 is there and OH is there, and this carbon contains negative charge. Here isopropyl group is there along with C double bond O, OH is there, right? If the ring opened by B pathway, same 5-membered ring will be present, right? In this carbon, CH3 and OH will be present, right? Here isopropyl group will be present, and in this C double bond O, OH will be present along, and this carbon will carry negative charge. So now tell which one is the major product. This is the major product as it is secondary carbanion. It is tertiary carbanion. Secondary carbanion is more stable than tertiary. We know that primary carbanion is more stable than secondary. Secondary is more stable than tertiary. Hence, this product will be formed on acid catalysis. It will form major product with the 5-membered ring. Here above the plane CH3 will be there. Here I didn't draw like this, right? But I draw CH3 in the above plane and OH in the below plane, and H will be up there, and it is C double bond O, OH. This is the major product, right? Before going to stereochemistry of Favorskii rearrangement, note that one point in cyclic alpha-haloketones, it results in ring contraction because one carbon migrates while the three-membered intermediate opens, right? Here, when three-membered ring is opening, one carbon will be migrating. Ring contraction will be occurring in presence of cyclic α-haloketones. Let us discuss the stereochemistry of Favorskii rearrangement. We all know that cyclohexane will be in this stereochemistry of cyclohexane. We know that, right? So this is an axial position, this is an equatorial position, this is equatorial, and this is axial, and this is equatorial, axial, equatorial, axial position, right? This is equatorial, axial, equatorial, and axial, right? This is axial and above the plane, axial and above the plane, equatorial and below the plane, and this is equatorial above the plane, this is axial below the plane, above the plane, below the plane, right? This is below the plane, axial below the plane, equatorial above the plane. We know that, right? This is equatorial, which is below the plane, equatorial and below the plane, and this is axial above the plane, axial above the plane, equatorial below the plane, equatorial above the plane, axial below the plane. We know that bulkier groups always be in the equatorial position. We know that in stereochemistry, we know that bulky groups always in the equatorial position, right? Equatorial position. If consider the examples for this, if the substrate is given like this, if the substrate is given like this, above the plane Cl will be present and isopropyl group will be present in the para position, right? The base has NaOMe, right? It is a alkoxide, sodium methoxide. What will be the product? We can write cyclohexane as like this, right? We can write cyclohexane like this. This is the above the plane. This is also above the plane in equatorial position. This group is present, and this is also in the above the plane. Here Cl will be present. No matter, this is sp2 hybridized carbon, right? It is in the planar structure. Now NaOMe, it is a base. Here also in axial position, in equatorial position, one hydrogen is there. Below the plane in axial position, one hydrogen is there, right? It will abstract one hydrogen. It will abstract one hydrogen, right? It will abstract one hydrogen, and it will form Cl minus sp2 hybridized carbon, right? No matter whether it may be equatorial hydrogen or the axial hydrogen, it will abstract the hydrogen at alpha position. Then the carbanion will attack the alpha carbon which contains leaving group. It will form, right? This is the structure formed after the formation of cyclopropanone ring. Here in above the plane, cyclopropyl group will be present, and this cyclopropane ring is present in the above the plane. Above the plane, the cyclopropanone ring has been formed. Now the base will attack to the carbonyl carbon OMe. OMe will act as nucleophile as well as base, right? Hence that OMe will attack the carbonyl carbon. It will form O minus and OMe. Here group is present, isopropyl group, right? Here three-membered ring is formed, right? Now we know that the negative charge will again delocalized, that will leading to open the ring either by this side or by this side. By if the ring opened by this side, there is a secondary carbocation, right? The negative charge will forming pi bond, and let us consider this ring opening as a path A and this opening as a path B, right? Let us consider path A. Cyclopentane ring has been formed, and in this carbon which is above the plane, C double bond O, OMe is there, and this carbon will carry negative charge. The isopropyl group will be present like this in path B. In path B, here if this opens also, here also it is in the above the plane, right? It is also in above the plane. C double bond O, Me is present. Okay, here negative charge will be occurred. Then both the cases similar carbanion were formed, and it is a 50-50 mixture. It is a the product is 50-50. The product is same, not 50-50 also. The product is same, right? 5-membered ring. After one carbon, this group is there. After two carbon, this group is there, right? Same product will be formed. Hence, what is the final product? This is also in the above plane, C double bond O, OMe, and which it is also in the above plane. This is the final product. Let us consider another example for this reaction. Let us discuss the mechanism. Let us consider the mechanism of this reaction. This is also α-haloketone. In alpha position, halogen group is there, and also in alpha position, one hydrogen group is there. The base will abstract the hydrogen and it form negative charge, which is attacked to CH2 group. The Cl will be eliminated and it forms 3-membered cyclopropanone ring. And again the base will attack the carbonyl carbon. As we know that NaOMe is act as nucleophile as well as base. First it will act as base, then it will act as nucleophile, right? Here also two types of ring openings will be there. If it is open like this, consider this as A, consider this as B. Let us discuss A, right? The ring will be opened. Here C double bond O, OMe will be present, and this carrying CH2 minus will be carrying negative charge, and another pathway is B, right? Above the plane isopropyl group is there. Okay, if the ring is opened by the B, it will forming CH2, then C double bond O, OMe, and this carbon is carrying negative charge, right? Here this carbon is carrying negative charge, here this carbon is carrying negative charge. This is primary carbanion and this is tertiary carbanion. This product is highly unstable and it is formed minor product, but this is a major product. After protonation it will give this product CH3, right? This is the major product of the reaction, and we can write the product formed as 6-membered ring is there. It will not undergoing any ring contraction as the α-haloketone is outside the ring, right? Hence, in above position, isopropyl group is there, right? In above position, and CH3 is there in the below position, and in above position, C double bond O, OMe is present. This is the major product, right? This is the stereochemistry behind this Favorskii rearrangement. Let us consider this example in presence of NaOMe, sodium methoxide. Alkoxide is there means it is forming ester, right? Let us solve by the stereochemistry, right? This is above the plane, the tertiary neobutyl group, right? And this is below the plane, right? It is in the below plane, right? C double bond O, CH2, Cl. Here alpha hydrogen is present. So after abstracting the hydrogen, it will form carbanion here. I will write here only. Right, carbanion is formed and this will attack to this carbon and the Cl will be eliminated as it is a good leaving group and it will form cyclopropanone ring. Right, again the NaOMe will attack, sodium methoxide will attack to the carbonyl carbon and the ring is open like this. This is A and this is B pathway. Let us consider this is B. Let us consider pathway A. Right, if path is formed, this is C double bond O and it carrying OMe and it is CH2 minus will be present. If I consider pathway B, it will form here new butyl group is there. It will form CH2 C double bond O OMe and along with this negative charge. This is not formed. This is a tertiary carbon and cyclic ring is there. It is highly unstable compound. This is the major product. This is the major product. After protonation, it will form this product. This is the final product. And we can write 6-membered ring. In this position, tertiary butyl group is there. And here, above the plane, methyl group will be present. Below the plane, C double bond O. Wait. Above the plane, methyl group will be present. Below the plane, C double bond O, OMe will be present. This is the stereochemistry of Favorskii rearrangement reaction. We can see the next name reaction in the next session.